Hello, everybody, and welcome to another episode of Analytics Mindset. In this video, we will go through another basics on programming video, more specifically, for loops, while loops, and other looping techniques and iterations in Python. Now, as a small disclaimer, this is probably the first video that is not entirely my original idea. I do always put the resources on whenever I get inspired to make a video in the description, but this one was also inspired by my manager, David Kirk. In case you want to know, I am putting the disclaimer there. This is the first video, while the code is original to me, it's not entirely my own idea. Going from that, and with the create do what is do, we will go over looping. And this is actually a follow-up of the Absolute Programming Basics with Python video. In case you have not gone through that video already, please go through it, or if you feel confident in your basic programming skills and concepts, you can just skip that video. If you get confused at any time in this video, please go back there and refresh your concepts before coming here. Make sure that you will not get lost on it. We will first refresh a little bit on our programming basics, especially in procedural programming. We will compare two variables to get a Boolean result. In this side, we have first variable, and I'm making that equal to 6. And then I'm taking second variable and making that equal to 8. So I have two variables here, one with the value of 6 and one with the value of 8. And I will use the if-else statement to compare them first. Why I'm doing this instead of going straight to the loops? Because this is the simplest way to see the control flow in action. You can take whole classes in control flow and the logic of programming. I am not going to go into detail about the theory behind it, but think it as the order of operations in math, a very advanced way of doing that. Remember in math, where you had multiplication, addition, multiplication will always be done before the addition, even though the multiplication could be all the way down to the right. A similar concept is. So we will go ahead and start going through this. Here I'm saying, if I was saying regular English, if first variable is more than second variable, then I usually read this as then the column, just to not complicate myself. You're going to do something. In this case, you're going to print the value of the first variable is higher than the value of the second variable. Else, or the same thing, if this is not true, print the value of the second variable is higher than the value of the first variable. Now, this may look straightforward, but I could have done anything here. This indentation is how Python knows what line of code to associate with what part of the chunk of code. You can hide it here, for example, as you can see here. Now, going a little bit more into this, I'm going to take all of this and execute it. As you can see, I got what I expected. The value of the second variable is higher than the value of the first variable because the second variable is 8 and the first variable is 6. It makes sense that it's going to print this. However, let's go ahead and change the first variable to 15 instead. I did make a typo. I'm going to make the first variable 15 instead. And now I could copy and paste this and just put it here in the console, or copy and paste this in the script, but that would be useless space when I can just take this. And because this is referencing first variable, and this is one of the important parts of variables, I updated the variable already. The variable is 15. Even though this was executed after this, I can run this, and it's going to show me that the value of the first variable is higher than the value of the second variable. That makes sense. 15 is more than 8. The first variable is higher. Now, after storing the new variable and executing that, we can notice that in the first case, we executed this. The value of the first variable is higher than the value of the second one. But we skipped this. The else condition did not trigger. It went through the if, it was correct, it ignored the else part. When we changed this to 15, it did the opposite way. We check first, is this true? It is not true. It skipped the print of the first variable, so this got skipped, and we got to the else path, and the else path triggered instead. Recall that lists, now going a little bit more into lists, are variables with multiple items inside them. In this case, I'm just creating a list with different programming languages names. I will go ahead and declare this and then print. That's going to give me the list here. Now, lists are a little bit more complicated because they are what we call iterable variables. We can go through each of these items through an iteration. And first, how do we access any of the individual items? With an index. You can do programming languages and then square bracket 0. That is going to give us Python. That is the first index there. We could do something similar if we just did 1 here. That's R, and that's Java. We can use the length function to see how long this list is, and that's 5. Makes sense, it has 5 items here. Now, lists are kind of important. We're going to go back into them when we go into the for loops. For now, just remember that lists are a little bit more complicated than other variables, and that allows us to do fancy stuff that we could do with 5, for example, or 1 to some degree. Now we're going to enter the while loops. The while loop allows us to execute code with a certain condition as we look into the if-else conditions that will terminate the loop if it's not true. So this is probably the simplest while loop that you're going to see. We are printing with I equals 0, and then say while I is less or equal to 9, print this is a while loop. We're gonna start here and execute. As you can notice here, it just will keep going and keep going and keep going. That is actually intentional. This is what's called as an infinite loop. Even though we put a condition here, that condition is never going to be met. I is equal to 0, and it's always going to be less than 9. Therefore, it's just going to keep going and going and going, consuming resources from my computer. I think you can hear how my computer is struggling going through this, so I will stop it. But you can see it just kept going and going, executing all of these lines of code. But we can be way smarter than that, and usually it's not a good idea to have an infinite loop unless you want it to go over and over again. Now, we do need to do a small adjustments to this. We have I equals to 0, and it needs to be less or equal to 9, but we're going to add this control here. I equals I plus 1. Now, if we take this and we just paste it here in the console, and now we print I is 1 instead of 0. If we do it again, you will see how it changed to 2. The reason is simple. This means take the previous value of I and then add a plus 1. And that's going to be the new value of I. We're going to restart this at 0. The logic behind this is you are going to iterate, you're going to go through the loop over and over again, but each time you're going to add 1 to the I, to the agents. And you can see what happens if we execute this. That only went through 9 iterations in the loop. After that, it was terminated. This is how you terminate while loops. You put some kind of control that is going to be increasing. Notice how this is indented at the same way as the print statement. It's because it's going to go through this. First, you're going to have your print statement, and then you're going to add 1 to I, and I will keep increasing. In the next one iteration, I is going to be 1 instead of 0. It's going to print another one, become 2, etc., 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 until it goes all the way to up to 9, and it just stops. This is a very good way to control your loops and make sure that they just don't run forever. There is a way more powerful abbreviation, though, that you may have seen, and it's I plus equals 1. instead of doing I equals I plus 1, we can do this instead. And this is going to do the same thing. You can see here, we just did exactly the same thing, but in a more concise way. It is just a preference. This is the preferred way for most programmers, but you could also do this, it's totally valid. It's just a shortcut for this. Now, we can also print the items inside of a list using iteration. Here in this while loop, just take a second to look at it. We have I equals 0 because we need to restart the index. Remember that now I is 10, and if we actually execute this, nothing happens because I is 10. It's more than the length of programming languages. That if we execute this, you can see that it's 5, so nothing will happen. We need to restart the index, and we do that by assigning, again, the value of 0. And then we do while I is less or equal than the length of the programming languages list, then print that item. Then do I plus equals 1 to make sure that we're counting those ones. And finally, if I is equal to the length of programming languages, so 5, then you're going to print stop the while loop and break to finish the while loop. We will see how that looks like. You can see here, we went through each of these programming languages names. So the same thing as we did before, we access first Python, then R, then Java, etc. But we do it in a programmatic way. We don't do it manually. And then we just print stop the while loop. So how the control flow will be is first this is read, then it's going to print the statement at I plus equals 1, and it's going to compare I to the length of this list. Because it's going to be 0, 1, 2, or 3, or 4, or less than the length of programming languages in the beginning, it's just going to go ahead and it's not going to execute this break statement. This break statement is important because it terminates the while loop. It tells the while loop, you are done, finish, no more. This is going to be omitted as well as this line, stop the while loop. But when we reach 5, when we have finished it up printing Julia, then we are going to go ahead and print stop the while loop. This is what you see here. And then we're going to break, ending the loop. There is a lot of ways we can demonstrate the power of while loops, but this is one of my favorites. We are going to go ahead and do a small, very small game right now. We're going to reset our index because it's 5 right now to I equals 0. And we're going to say, while I is equal to 0, first you're going to print this. We're going to be simple video game. And then print, do you want to go through door 1 or 2? Then this is a new function. We are asking the user, tell us what door you want to get, 1 or 2. Now we're going to tell them what door they ask. We're using F. F basically allows us to print the variable that is going to be door. If the door is equal to 1, you have won and you are done. We terminate the loop by saying I equals 1. Else, if the door is equal to 2, we're going to say, sorry, you have lost, and also finish the game. And if the output is anything else that is not 1 or 2, we're going to just say output is not valid, try again, and then print game is restarting, and print empty blank space. We're going to go ahead and execute all of these things. And you can see here, we start with this path. Welcome to this simple video game. Do you want to go through door 1 or 2? Please type. And with the input function, I'm going to go ahead and print 1. Then it's going to tell me you have chosen door 1. Congratulations, you have won. Let's do the same thing now. I'm going to take all of this again. But instead, I'm going to go through door 2. You have chosen door 2. Sorry, you have lost. And then the game finishes. And at that time, we will put a crazy value like 989. You can see you have chosen door 989, and then it says output not valid, try again, and say game is restarted. And then it's going to give us the same thing. So the game's still running here, you can see. I just made it go back to the main loop. We can say 45, and it's going to throw me back again to the main loop until I do something that the game knows I want to finish, like 1. And if you notice here, if you paid attention, the input function stops the loop there. It doesn't go and execute more stuff until I have put something there. That is one important part of control flow, and how you can elaborate into these loops a lot and basically do anything you want. You could do very complicated loops, and to some degree, this is a very powerful programming concept that allows you to build very, very complex stuff by just using control flow and deciding some simple rules. You have this explanation here again if you want to go back at it. This is a little bit more complex on the programming side that we have done so far, but again, you can think of this as a very, very simple video game. A ton of video games, besides their user interface, obviously, are nothing more than very, very advanced for and while loops combined, or in whichever programming language they are written on, but it's the same concept. You do stuff while you're somewhere, like for example, while your battery is still on, and then if you pass this level, you go to the next level, etc., etc., etc. So you can get the concept how this can be elaborated and expanded to become way bigger than this. Now, going to for loops, as I mentioned before, they are very useful to go through iterations of an object, an iterable. We're going to do this for I in the range of the length of programming languages. Print the programming languages with that index. There you go. We have printed every single value here, the same thing that we did before, that we print with this while loop, although it's probably simpler in the for loop to do this. Now, if you don't recall from the absolute Python basics video, we first have programming languages. Let me show you this. That is just this list. Then we have the length function. The length function returns us the length of this, 5. The range function gives us a range between 0 and 5. So we are printing from 0 all the way to 5. We're printing every single value inside of it. And again, as you can see here, we first do the for I in the range of this, and then print programming languages I in square brackets. Now, I is an arbitrary naming convention, stands for index. You could put anything. You could put K, you could put program, you could put whatever you want. I just call it I because I follow the custom. We can use any other valid variable name. As long as it's valid within Python, you can use it. But we can also iterate through a string, actually. We are going to call this new string. This is a string. And then we're going to do a for loop for letter in new string print letter. As you can see, we have gone through each single letter here and divided it, including the spaces here, and just printed it as this is a string. Disclaimer here, this is probably the basics of NLP, natural language processing. You iterate a lot through a lot of stuff in NLP to get fancy things like sentiment analysis, getting rid of bad words, or your corpus, etc. Just quite a bit of things that you can build upon that. But this is the simplest way, probably. Take a word, in this case, take a sentence, and you are just splitting the different letters in that sentence. We can get a way fancier output than this, for example. Now, the power of for loops resides on this. We can say first, letter number is equal to 1. This is the first letter. and then say for letter in new string, print, this is letter number, the letter number of the string letter, then printing the letter. Then you are going to add 1 to that. And if the letter number is equal to 17, you're going to print a new message saying this is the end of the string with a length of len new string. Okay, what just happened? We got a very interesting output here where, if you notice it, we have gone through each single one of these letters, but we have also printed what's their position in the string. T is letter number 1, for example. This A is letter number 9, and G is the final letter 16. Now, the very useful part of this is that new string could be anything. Let's do instead new string. This is for the video demonstration. That's a longer string than before. And now we're going to do the same thing. You can see here, everything was good. It printed everything besides this. This did not work because the string has a length of 35. And I explicitly said, if the letter number is equal to 17, then you're going to return this string. There are ways of fixing that, but I was going to show you the flexibility of for loops. You don't need to refer to a single number. You can refer to the actual length of the string and go through the whole length. And that is how you can do a lot of automation, for example. You could think about this as organize me these files, search into this directory, and then modify these files, create these files, or delete these files until you have nothing else to do. The same thing applies here. And that is one of the most powerful parts of for loops for automation. Machine learning models also benefit a lot about this concept because a lot of outputs in machine learning, especially in sklearn and stats models, are nothing more than very complex while and for loops that are going to get you an output formatted properly and then just print it to you in the console. You can think about a ton of ways you can organize it. I have already shown in my logistic and linear regression videos that you're going to see somewhere on the screen that you can just create fancier outputs with the coefficients and the intercept instead of just having the usual method to access them from sklearn. We will demonstrate the power of loops by combining for and while loops into our door game, but we're going to make it a little bit more complex this time. We're adding a verification here to see if the user can go back to the game. So we're going to go ahead and say I equals 0. We're going to declare a list. The sum of the numbers is equal to 2, 5, and 12. Then, as you can see here, this loop is more complicated. Everything here stays the same. All of this stays the same. But if we get to the output not valid, you are not going back to the game that easily. First, the game is going to ask you to input the correct sum of the following numbers. There is a list that we already declared here. We're going to show the numbers to the user first, and then we're going to ask the user for the input. If that input is correct, it's a sum of the numbers, you're going to print thinking, and you're back into the game and throw you back to the beginning of the loop. If not, you're going to say, sorry, that is not correct, you're out of the game. We will go ahead, take all of this, and execute it. If we do 1, as you can see, you have 1, nothing changes. Let's do the same thing. Now we're going to do 2 instead. Nothing has changed. This time around, we're going to do something like 55. There you go. Output is not valid. If you want to try again, input the correct sum of the following numbers, 2, 5, and 12. And because I know this beforehand, I know it's 90. It threw me back to the name. So we went back. First, it executed the rest of the statement, and then I came back to the game, and I can say 1 and win. But now let's go to what happens if we actually lose the game through this. We're going to put something like 67, and then we're going to put 58, 4. I know that it's not the sum of the numbers, but it's going to tell me that it's not correct, and then I'm out of the game. And then the game is going to be over, and as you can see here, because this icon is not red, it is done. I have finished the game successfully. You can imagine that you can combine this with functions and make procedural programming even more powerful, because you can have loops inside functions, and well, functions inside loops, as I have shown it here, all of these are functions. But this is a very powerful tool for analytics and automation. If you understand loops, you can do a lot of stuff in Python and any programming language, for that matter, that has simple loops. But yeah, you can do almost anything in a while loop, and they just come back at it and restart the loop. And with that, I will finish this video. I hope that this was useful for you. Again, remember, if you like this video, please drop a like, put a comment. I would love to get any feedback that you may have. And if you're interested in my content, please subscribe as well. And this is going to be, all this code is going to be in the description as always, as well as some other further resources for you to keep learning if you want to. Thank you. Have a good day.